Welcome to this fifth tutorial on 885 programming, and the topic of today is status register, or these flags. As we can see here, this stands for the sign flag, this stands for zero flag, this stands for auxiliary carry, this stands for parity, and this stands for carry. So we will study this, and for that purposes I have already typed in the program and I have executed this. So this shows the status after the execution. You can type this program and see the execution step by step also from our previous videos. So for today's purpose I have moved a value of 0 AAH, that means AA in hexadecimal into A register. H is for hexadecimal and 0 is appended before AA to indicate to the 885 software that this is to be treated as a number, means whatever is written after 0 is to be treated as a number. So AA will be there in A register. After that, in B register I have moved the hexadecimal value of 70, and then I have performed this addition ADDB. It will add the contents of B register to the accumulator and it will store the result in accumulator again. And halt is used for stopping the execution of the program. So let us perform this addition manually first. So we have this number AA in hexadecimal. This is its binary representation, lower 4 bits and higher 4 bits, and similarly for 70. So we have added them. This is for carry and this is the result. So if there is a carry at the ninth position, means starting from this first position, second position, and this is the ninth position. So if there is a carry at the ninth position, then definitely this carry flag will be set to 1. It is as simple as that. So after execution it happens that this carry appears and this carry flag is set to 1. After that we come to auxiliary carry. Now what is auxiliary carry? If there are two numbers which are added and the result of addition is such that in the higher 4 bits, if there is a carry, means at the beginning of the higher 4 bits, these are the lower 4 bits of this number and this is the higher 4 bits. So if we traverse from here to here, then at the beginning of the higher 4 bit, if there is a carry, that means if there is a carry at this position, then this is called as auxiliary carry. So in this case it happens that there is a auxiliary carry, and for that auxiliary carry is set to 1. It is very useful in certain calculations, as we will see in our next videos. So auxiliary carry is meant for this, and this is the program which I have already typed in and executed. You can see the contents and verify it for yourself. Now we'll move on to 0 and parity. So first we will tackle the case of 0. So if the result is such that there is a 0 somewhere, means I have moved a value of 03 in hexadecimal to A register and B register, and then I have performed a subtraction by using subB command. So this command will subtract B register from accumulator and store the result back into accumulator. So after executing this program, you can see that the result is 00 here, and that is why this 0 flag is set. So if the result of execution of any program is such that in accumulator a 0 value appears, so this 0 flag will be set to 1. Now this parity flag is also set to 1. What is this parity flag? It indicates that if the result in accumulator has even number of ones, then it will be set to 1. And if the result in accumulator has odd number of ones, then it will be set to 0. Means if we combine this parity bit and accumulator, the take home message is the total number of ones should be odd. So in this case, when there is a result of 0, so all the bits will be 0 in binary form, so it will make itself as 1 combined with the accumulator. So there is a there is an odd number of ones at the end, so parity bit is set to 1 in this case. If we have something like this, 5 and 3, and we are subtracting 3 from 5 by using subB command, then definitely 2 will appear as a result, and the binary equivalent of 2 is 10. So it has odd number of ones already. So if we will combine this parity bit with the accumulator bit, so we do not require to make it 1 because there are already odd number of ones in the result. So this parity bit will remain 0. So this is all about parity and 0 flag. And now we will move on to this sign bit, which is very important bit. So this subtraction in 885 happens by using the 2's complement operation. So I have already typed in the program and the results are already there, but before that we will first see subtraction. So suppose I am subtracting 05 and 07, means I am subtracting 07 from 05. So you can see that the result will be negative, and these are the rules of the subtraction. So at first 2's complement of the subtractand is found. So this is the subtract hand, which happens to be 7's binary equivalent. So we have to find out its 2's complement. So to find the 2's complement, we have to first find the 1's complement, and then we will add 1 to the least significant bit. To find the 1's complement of this number, we have to flip each digit. Means 0 will be converted to 1, this will be 1, 1, 1, 1, and these 3 will be 0. So after we have obtained the 1's complement, we will add 1 to it. So after adding 1, we will get result as this: all 1's, 2 zeros, and then 1. So we have found out the 2's complement of the subtract hand. The first number is kept as it is, and then we will perform the addition as per the second point. So addition is performed, and after the performance of addition, we have to check these two. If the final carryover of the sum is 1, so there is no carry, so we do not fall into this case. If there is no carryover, then 2's complement of the sum will be the result, and it is negative. Means in our case there is no carry, so 2's complement of this will be our final result, and the result is negative because we already know that 5 minus 7 will be minus 2. But how will this be done in 8085 microprocessor? It will store this value as it is in the accumulator. So this 1111 happens to be F, and 1110 happens to be E, and you can check that after the execution of the program, FE is stored here. So now the result is negative. So how will it indicate that the result is negative? Since the result is negative, the sign bit is set to 1, and also this carry bit is set to 1. Sign bit is set to 1 means that definitely the result will be negative, and carry bit is set to 1. Although there is no carry, but carry bit is set to 1, it indicates that the result is in its 2's complemented form. So if you want to get the proper result, you have to again take the 2's complement of this number, which is indicated by this c is equal to 1, and then you have to apply a negative sign before that, which is indicated by this sign flag. So in other case, suppose we had a carry in the final answer, so in that case we already know that this number is greater than this number in the second case. So what will happen is this carry flag will be 0, which indicates that the result is positive and it is not in its 2's complement form, and sign bit will be 0 also in that case. So this is how this sign bit works in 8085 processor, and this is the flag register, and we will see some other operations in the next tutorial regarding these flag registers. So keep watching our channel and subscribe to our channel for more video updates.